Good afternoon. We'll be starting in 2 minutes.
Good afternoon, ma'am.
Good afternoon. So let's start. Today is a division session, so I will go through the all the slides, each uh, each slide and discuss. Then we'll do some problems. Do you have any question?
No, ma'am.
Okay.
Ma'am,
Yes.
objective or subjective?
What? You are not audible.
Yes, ma'am.
Your voice is not clear. Can you tell me again?
Ma'am, exam theater online, but subjective or objective?
It will be that way in the assignment. In the assignment, the type of questions you have faced, it will be almost same. So it is mixed
Okay.
of both, yeah. Because problems are not objective, so it will be little bit you have to calculate, and the theory questions are like that, simple.
Okay, ma'am.
So the first lecture, Sarah talked about the overall overview of the solid operation or solid fluid process. So you know that this is the interaction of fluid with gas and liquid. And the process is generally applied in sizing of the solids, size reduction of the solids, transportation, chemical synthesis, mineral beneficiation, drying, cooling, coating of the solids, and separation of the contaminants. Then comes a broad classification that how this separation is happening. Mechanicals, under mechanical separation, it comes the transportation, material, size reduction, enlargement, mixing, filtration, flotation, sedimentation, etc. Then under electrochemical, electrostatic separation, magnetic separation, electrodialysis, electroosmosis, electrophoresis, ion exchange, power vaporation. And under chemical process, it is the crystallization, drying, absorption, chromatography, etc. So these are the different methods of the mechanical process of particle separation. These are the electrochemical process. And finally, these are the chemical processes of different types of beds, crystallization, adsorption, copper extraction, drying, etc. So these are the type of chambers are used for particle separation like gravity chamber, cyclone separator, bag filter, spray tower, electrostatic precipitator. Next, Sarah taught the transportation of materials, that how the materials are transported from one place to another place. First one is the conveying. So solids not finely crushed are transported by railways, trucks, ropeways, ships, conveyors, etc. Pipelines, also the conveyor belts are used, pipelines are used, pumps are used for the conveying of the transportation of the materials. Then how the size reduction happens. Mainly size reduction is happening because of the compression, impact and attrition. So there are crushing method, there are grinding method. And based on compression and this compression, impact and attrition, these three science is used to crush the materials into smaller particles. So first one is the screening. Screening, you know the screen you have seen where there is a mesh, different size of mesh, and through the difference of the mesh sizes, particles are separated. This is the filtration process. This is the separation of solid particles from solid fluid mixtures by a filter medium. Next is the separation of the particulate matter. Particulate matter ranges from 2.5 to 10 micrometer to micrometer. Then comes the settling and sedimentation. This works based on the gravitational force of applied onto the particles. This is mostly applied for the thicker particles or heavy particles. Then the flotation process, that means the smaller particles are separated with the flotation process. In flotation process, the particles are suspended and with the depending on the hydrophobic or hydrophilic nature of the particles by the introduction of gas bubbles. They are adsorbed on the surface of the gas bubbles. Next is the agitation and mixing. That so if we mix the solution in a good way, good mixing, then also after the homogeneous mixing also the particles which are not very heavy, they can suspend or finally settle down. Next comes the thermochemical process. The drying process is one of the thermochemical process. It is a process of removing liquid from a solid at a temperature below the boiling point by circulating air or some other carrier gas over the solid. Next is the crystallization process. This is also one type of separation process. Then is the leaching process. The process of separation of solute from a solid by an insoluble solvent is called leaching process. Like the grading of bauxite using NaOH solution at 150 degrees centigrade. Next is the calcination process, the conversion of concentrated ore into oxide are heating by heating in absence of air. So in calcination process, no air is present. This process helps in separating carbon dioxide, sulfur dioxide, and other impurities. Then there is a roasting process. Then after reaction process also we can separate particles chemically. Next comes the electrochemical process. So under the electrochemical there is electrostatic separation and magnetic separation. So it is a process of separation of solid particles by means of utilizing an external field applied on the charged or polarized bodies, and in magnetic separation instead of electric field we use magnetic field. So this is the electrodialysis process. We have seen the videos in those lectures that how this electrodialysis, the separation of positive and negative charge happens, the process by which charged particles migrate by diffusion and convective flow toward a less charged area by electroosmotic effect. This is the electrodialysis. Then there is the electroosmosis. It is a transport process of salt ions through selective semi-permeable membrane. So in the electrolysis there is no membrane, but from higher concentration zone to lower concentration zone, charged particles are flowing. But in case of electroosmosis, there is a presence of semi-permeable membrane through which maybe cations can pass or anion cannot pass based on our requirement. We use the membrane. You can change the membrane. Next one is the electrophoresis. Electrophoresis is a separation technique to separate biological molecules such as DNA, RNA, or protein based on their size and electrical charge. Next comes the ion exchange. Last one is the Parr evaporation, where it is a separation process of binary or multi-component mixtures of liquids based on partial vaporization through a polymeric or ceramic membrane. Next is the gas permeation. Then in industry, these all type of separation processes.
Yes, electrochemical.
Yes.
Gas permeation.
Yes. Gas permeation is also
comes
under electrochemical. So it is a permeable membrane where only the gas can pass through and the particles remain on the another side of the membrane, and that is how they are separated. So it is written that it is a fractionation of gas mixtures based on permeability to gas according to a dissolution diffusion mechanism through a membrane. That means there are mixtures of gases, so the membrane is made in such a way that some gases can pass through that which we don't want. We can pass them through the membrane, and our desired gas is remain on the other side of the membrane, and that is how we can separate it. So it is also comes under electrochemical process. Next is that everything is used depending on our product and cost and everything. Different types of separation processes are used in industry. Next comes the solid feed system. So under solid feed system, gas solid, liquid solid, and gas liquid solid, all three are together. So it is a three-phase system. So it has huge industrial applications in food processing. In every industry, you need to separate things after the final product. So in every cases, this unit operations, the solid feed operation or separation methods are very, very important. So in food processing unit, pharmaceutical unit, biotechnology, oil industries, mineral processing, metallurgical processing, detergent industry, paint industry, plastic industry, everywhere these are used. So these are some of the specific solid catalyzed gas phase reactions. So when SO2 from SO2 to produce SO3, we need solid catalyst. Similarly, here also, in the combustion also some catalysts are used where there is a gas solid reaction. These are all some of the commercial applications they have shown. This is the filtration process used commercially. Production of fuels in every stages you need to separate and check the differentiate the product. So this is important. So this is just the overview. Next is the what are the particles. So why particles are important and what is their properties. These are the shape, size, strength, porosity, zeta potential, particle outline, true density. Everything is important for the segregation. These are properties of a particle. So we need to check the flowability of a particle, reactivity, quicking, attrition, adsorption, mixing, segregation, and slurry properties of that particular particle which we want to separate. So there are different types of particle shape can be there. This is the shape factor, depends on the aspect ratio, length by breadth or breadth by length. Then the sphericity of the particles, roundness of the particles, and particle outline. So this is the shape of irregular particle and this is the shape of equivalent sphere particle. So these are the types of particles can happen. So depending on the particles, different particles, we can calculate the surface equivalent diameter, volume equivalent diameter. These are the shapes of particles. You can see that in case of cylinder and how the projected area and for two-dimensional body and three-dimensional body it is different. So for a rod the aspect ratio is 0 and for a spherical particle the aspect ratio is 1 and any other particle comes between 0 to 1. So the definition of sphericity, it is very important. The definition of sphericity is the surface area of a sphere having the same volume of the particle and surface divided by surface area of the particle. So the sphere and the particle and its equivalent volume sphere. That means the sphere and the particle have same volume. That if when they are same, then only we can calculate the sphericity by surface area of the sphere, which is a known value, and surface area of the particle, which is also known value, and then the ratio of them leads to the sphericity. So the derivation of the sphericity I have done in the lecture. So from where this is coming. These are the typical values. Then they talk about the particle outline. Then the size of the typical powder products like powder metals have a size of 1 to 10 micrometer. Then electronic materials 10 to the minus 1 to 1 micrometer. Then fume silica is in the range of 10 to the minus 2 to 10 to the minus 1. Pellet crystalline industrial chemicals are of bigger size. Then comes the granular fertilizers. Then the detergent size is there, and finally the powder size is there. This is a gel dot powder classifications where there are 4 type of particles are there. Particle A, B, C, D. So D type of, so here the A, B, C, D. This is the A is the aerable particles, B is the bubbles, B is the bubbles, C is the cohesive particles, and D are the sproutable particles, which are of bigger size. C is the fine particles, and B and A comes in between them. So the size of the powders, different types of powder, ultra fine, super fine, granular powder, granular solid, broken solid, all are given. Then they talked about what is zeta potential. It is a measure of the magnitude of the electrostatic or charge repulsion or attraction between the particles in a solid suspension. So I have in the videos in the lecture I have said what is the zeta potential. So you can go through that lecture and recollect it. So this is the zeta potential formula. So now what is the significance of zeta potential? So as the absolute value of zeta potential is larger, many colloidal particles show good dispersibility as the electrostatic repulsion becomes. Zeta potential means every particle has some kind of charge on their surface. So when these charges are very high, like you can see from the charge, that when the charge between the particle is plus minus 61, that means above 60, they are excellent stable. That means they are stable for forever. Next come the good stability in the range of plus minus 40 to plus minus 60. Then moderate stability plus minus 32 plus minus 40. Incipient instability is plus minus 10 to plus minus 30. That means when you try to form an emulsion, it will settle down after some time, after some minutes or after some, 1 day and two. Rapid coagulation or flocculation means you mix the solution or you are creating an emulsion. It is instantly it is settled down. Such as you have seen the iron oxide. If you have iron oxide, if you try to mix with the mix in the water, you will see that the immediately after 1-2 minutes or after 5 minutes that will settle down in the bottom. So that is not called a good colloidal solution, because colloidal suspension should be called where the particles are separated and segregated because of their repulsion in the electrostatic charge. So this is the significance of zeta potential. So based on that, some problems are there. You can solve it on your own. Then the last chapter of the first week was the particle size distribution. So when the particles are monodispersed, these are the shape of the monodispersed particle. That means all the particles in that region have almost same average diameter, and this is the polydispersed particle, that is the different shape of particles are together. So this is the after crashing, this is the shape of the particle. Monodispersed particles comes in the single range, and polydispersed particles diameter distribution comes in a bigger range. So this is their volume, the size distribution by number, volume and surface. Then comes the segregation of particles based on the size. So that is the screening method. So we have seen this kind of meshes everywhere. So they are stacked serially, and that is how they are separated in each of the platform. So the solids that pass through some the bigger particle, this type of particles will pass through this one, but it will be retained in that particular mesh. This is a problem depending on that. Now comes the mean square diameter. There are different type of mean square diameter. That is the arithmetic mean, quadratic mean, cubic mean, geometric mean, and harmonic mean, which is applied in different cases. They are calculating the mean size based on the volume. So mass mean diameter is this one. Then comes the mean size based on the surface. So that is called the Sauter mean diameter, which the expression is You can see ds equals to 1 by xi by dpi. Dpi is the average diameter of that size, and xi is the fraction of particular size range present in the mixture. So these are the methods for particle size measurement. How we calculate the measurement of the particle size: by sieving, by sedimentation, by microscopy, permeometry, electrozone sensing, and laser diffraction. But with the help of these measurements, we can measure the particle size. Next is the importance of particle size reduction. So why we need to reduce the particle size? Because to obtain workable size, to obtain powders, obtain specific shape and size, increase reactivity, permit separation of unwanted ingredients. So you know that when the particle size is reduced, its surface to volume ratio increases, right? So when some particles are suspend to volume ratio is increased, then the reactivity or the capability of that particle to perform in a reaction simultaneously increases because of their high surface to volume ratio. So it is important to reduce the size to get and to get some enhanced quality or enhanced reaction. So again, it is said to improve uniformity of the mixing. If the size of particle is small, the flow of powder dies into during the compression of the tablets is effective. To rapid the effective drying, if the size of granules is small, then the drying of granular mass becomes rapid. So that is just I said that because the surface to volume ratio is increasing, so the whole outer surface area of a particle can perform in any kind of chemical reactions or mass transfer, heat transfer. So when the whole area is performing, it will be more advantageous and rapid. So these are the examples of the size reduction. So now you see that how compression is done, particle disintegration by two rigid forces, right? Impact is particles break by a single rigid forces, right? Like that we are throwing a particle in one direction. That is the particle breaks by single rigid forces. When we are applying force from two sides, that is compression. Attrition is we are particles scraping between two surfaces, and shear is the just we are moving the particles in an opposite direction, and because and tangential forces are applied. Okay, and non-mechanical is introduction of energy, thermal shock, explosive shattering, etc. So this is how size reduction in the crusher. So this is the different type of instruments, equipments used to reduce the size. So what is the mechanism? In case of impact communication, kinetic energy of the particles is used to generate the degree of deformation that is required for fracture. A material is said to be brittle elastic if the deformation of the product is initially proportional to the applied stress and the fracture occurs suddenly. In the linear range, the particle deformation is elastic and reversible. But as soon as the higher, that means that when are applying the particle stress in linear range, if we withdraw other force, the elastic material will return to its original shape. But as soon as the higher stresses are experienced, the material strength is exceeded locally and cracks are triggered. The cracks grow extremely fast and lead to the destruction of the particles. So this is the fracture mechanism, and you can create or you can measure the critical parameter for each and every type of particles. This is the formula of stress field. This is some of the important points here. Then comes the power requirement and efficiency. That to need when stress is applied, materials are distorted and strained. What necessary to strain is stored as mechanical energy till the ultimate strength is reached. Energy goes into increase. Energy goes to increase in surface area, and excess energy is liberated as heat. So this is the efficiency of the crashing. So surface energy created by size reduction mechanism divided by energy absorbed by the material. So this is the ratio of these two is called the size reduction efficiency. So this is the mechanical efficiency, energy absorbed by the material or energy input. Okay, this is a problem based on the size reduction efficiency. This is the properties of solids. It is recapping. Okay. So mechanism we have just seen. So what type of equipments are used to reduce the size? So first one is the crusher, which uses the compression method. Okay. So examples of different type of crushers is jaw crusher, gyratory crusher, roll crusher, hammer crusher. Next comes the grinder, where we are using the impact sign. So hammer mills uses the impact grind. Hammer mills uses the impact method. Attrition mill uses the impact method. Rod mills, ball mills, etc. Ultrafine grinders uses the shearing method, where particle size is less than 6 millimeter, and the final cutting machine uses the shearing laser. Knife cutters, shredders, dicers, etc. So again, the types of it is explained in a detailed way that what is the crusher mechanism is compression. So you can see that very bigger particles are feed of this crusher, which is a range of 1500 to 40 millimeter, and when the finally they are crushed, and final product size in the range of 50 to 5 millimeter. Next is the grinder. Here the feed size is little bit less than the crusher. So here the feed size includes 50 to 2 millimeter, and product size is 5 to 0.1 millimeter. Then comes ultra fine grinder, which is another type of size reduction equipment, where the shearing method is used. And here the feed size is less than 6 millimeter, and product size is very small in the range of 1 to 20 micrometer. Finally, the cutting machines, where they uses the shearing and laser. Here the feed size have definite size and shape, and the product size will be in the range of 2 to 10 millimeter in length. So this is a working principle of one type of crusher, which is a jaw crusher. Here the pressure is achieved by the two jaws. You can see the two jaws of the crusher, of which one is fixed and the other is reciprocating. So that is how they are. This one is fixed and that is reciprocating, and they are reducing the size of bigger particles. This is the capacity of jaw crushers. So these are some of the standard equipments used in case of size reduction in India. These are the advantage or disadvantage. So simple structure. By jaw crushing, we get simple structure, inspect, repair, maintenance are convenient, reliable work. small machine body, easy to device. Disadvantage is lower productivity, high power consumption, bigger vibration, small crashing ratio, uneven particle size. Okay, so both of the qualities are there in the jaw crusher. Next is the gyratory crusher. In gyratory crusher is similar in basic concept to a jaw crusher, consisting of a concave surface and a conical head. Both surfaces are typically lined with manganese steel and surfaces. Last one is the cone crusher. So it is a cone-shaped crusher. Similar in operation to the gyratory crusher with less stiffness in the crushing chamber and more of a parallel zone between crushing zones. So all of them have advantage and disadvantages. Last one is the smooth roll crusher. That is the particles are getting crushed where between two rolls. So here you can see from the video through two oppositely rotating grinding roller with the aid of friction and gravity. The material will be beat into the crushing chamber and make it squeeze and grind and broken. So this is the derivation we did in the class, that how this force and the angle at which the particle will get crushed is calculated. This is the capacity of a roll crusher. There is the tooth roll crusher. That means the rolls have some tooth periodically on the surface of the roll crusher. So you can see that the crusher is made up of a toothed roll assembly as shown in the figure. It is designed to reduce larger feet sizes. Okay, so this is the toothed roll crusher. All of the crushers or equipments have some advantage and disadvantage, so we need to balance it. Then is the tumbling mill. It is a cylindrical shell slowly turning about its horizontal axis and filled about half of its volume with grinding medium. This is the ball mill, where you can see the inside the mill. This is a cylindrical type of rotating mill in where this is horizontally placed. So by rotating on horizontal axis, the ball mill effectively turns hard materials into the powder. So our materials is inside this chamber. There are balls, and they are getting, when this whole chamber is rotating in a horizontal direction, these balls are helping to crush the materials. So this speed is usually 50 to 75% of the critical speed, which would just cause the charge of the balls and feed material to be centrifuged. This derivation is also done from that how this critical speed of the ball mill is calculated. I think you remember. If you forget, you just go through the lectures, and these are some of the problems done. This is the rod mill, where inside the similar chamber, instead of balls, there are rods. Okay, so in the rod mill, high carbon steel rods about range from, when new, between 2 to 4 inches in diameter instead of ball, and extending the whole length of the mill are used. Next, everything has advantage, disadvantage. So this is the comparison between all the mills: rod mill, ball mill, tube mills. So you can see that depending on the requirement, we can change our mills. This is the hammer mills. This is the capacity of hammer mills and its advantage. Finally is the attrition mills. So the material, especially grains, are rubbed between the grooved flat faces or rotating circular roughened discs. So you can see how attrition is applied in these mills. Next is the fluidized energy mill. In the fluidized energy mill, you can see that consists of a hollow toroid that has a diameter of 20 to 200 millimeter depending on the height of the loop, which can be 1.2 to 2.4 meter. So when different types of equipments are used depending on this factor, that stressing mechanism, size of feed and product. Then because the type of materials we are using in jaw crusher, we cannot use it in rod mill or ball mill, because that will, the bigger size of the particle will damage the ball mill chamber. So depend size of the feed and product is very important. Then comes the material properties, carrier, medium, mode of operation, capacity, combination with other unit operation. So these are the factors affecting the choice of the equipment. Okay, so this is for the second week. In the third week, sir has taught the size enlargement technique. So size enlargement is the process by which smaller particles are put together to form larger masses without changing the original particle's identity. So, and it is mainly associated with the pharmaceutical, agricultural, food industries, minerals, metallurgical, and ceramic industries. So sometimes it is difficult to uh, take out very small size particles. So in that case, if these small size particles come together and form an agglomeration or bigger particle, that particle will be easier to separate. So in that cases, size enlargement is important. So now they have talked about why enlargement is important. So I have just said that to reduce caking and lump formation. Then, so you have seen maybe that powders, when powders are kept together, they form a kind of lump, which is bad. So to reduce the lump formation, size enlargement is important. Creation of non-segregating mixtures of ingredients, production of a useful structural form to improve flow profiles, flow properties, to improve product appearance, control the porosity, control the solubility, etc. So these type of things are used in size enlargement process is used in pharmaceutical industry, then chemical industry, then in the food industry, then animal food industry, mining or metallurgical industry, ceramic industry, agriculture industry, construction industry, cosmetic industry. That means all type of industry they can be used. So now what type of bond they will be forming with one another is called the interfacial bond. So Van der Waals forces due to absorbed liquid layers, liquid bridges, electrostatic force and solid bridges. These are some of the forces they will be bonding with each other. So what is Van der Waals force? It is a very weak attraction force between solids. Okay. But the Van der Waals force is weak. The energy of these forces is of the order of 0.1 electron volt and decreases with the sixth power of the distance between molecules. The range of van der Waals forces is large compared with that of the chemical bonds. So this is how van der Waals forces are calculated. Now forces due to absorbed layer. So liquid layer can be absorbed on the surface of a particle. So that is called forces due to absorbed liquid layer. Liquid bridges can form between the particles. Right. In addition to the interparticle forces resulting from absorbed liquid layer, the presence of liquid in the surface of particles affect the interparticle forces. So these forces are usually negligible in magnitude compared with forces resulting when the proportion of liquid present is sufficient to form the interparticle liquid bridges. So this is how interparticle liquid bridges are formed. Then is the forces due to liquid bridges among themselves. Okay, so these are the different types of forms they are creating. Next is the electrostatic forces. So electrostatic forces generates between two particles due to the potential difference between two particles. So that is how they are separated. So electrostatic charging of particles and surfaces occurs as a result of friction caused by interparticle collisions and frequent rubbing of particles against equipment surface during the processing. So this is one kind of force. Next is the solid bridge. That means the permanent bridge, crystalline bridges, liquid binder bridges, and solid binder bridges. Now the size enlargement rate processes. So by compaction, granulation, encapsulation, pelletizing, and agglomeration, we can enlarge the particle size. So excipients for granulation can be largely divided into categories as bulking agents, functional additives, others, etc. Next, what are the bulking agents? That is sugar, lactose, dicalcium phosphate, starch, pre-gelatinized starch, microcrystalline cellulose. And now you can add functional additives like binders, disintegrants, lubricants, stabilizing agents, etc. Okay, so these are the different types of processes explained here. These are the size enlargement method. Just I have said that how size enlargement happen: granulation, compaction, extrusion, sintering, spray, drying, and prelude. So now comes the types of granulation. So there are dry particle which will do the dry granulation, and there are wet particle or solid fluid mixture of particles. They will do the wet granulation. In wet granulation, aqueous and non-aqueous methods are present, and in dry granulation, dry mixing, slug, deslug, compaction methods are present. So this is the schematic of granulation. Now how wet granulation happens. So these are the steps. So in the first process, the void between particles is replaced by liquid, which is added as liquid drop. Weighting is governed by the surface tension of the liquid and the contact angle with the particle. So this is the second nucleation stage. Stages of weighting, that how it is weighting the surface, how a liquid is weighting a surface. Then is the equation for the nucleation stage. Then comes the drop control nucleation. So each droplet should land on the powder without touching other droplets and sink quickly into the powder to form a new nucleus granule. These ideal conditions are called the drop control nucleation regime. This is the surface formation, powder surface by spraying drops and number of nuclei relation. So this is related to the size enlargement process. This is the expression of critical stroke number. This is the granule deformation, that is granules can also be deformed. This is the mechanism of dry granulation, then particle rearrangement, particle deformation, particle fragmentation, particle bonding. All comes under size enlargement process. elastic and plastic deformations, etc. Next is the next is also going the same topic, wet granulation or granulation equipment. There are different type of granulation equipment like tumbling mixer, fluidized bed, centrifugal granulator, spray granulator, filling, etc. So different types of granulators are described here. These are the bulking agents. Then these are the functional additives we have just read, and these are the binders, right? So different types of materials are there to enlarge the particles and or reduce the friction between the tablet and the dimetal surface. So this is the third week lecture. In the fourth week, that has taught about the flow past the cylinder. So flow around a body. So flow when a fluid flows, it maintains it a proper direction or motion. And when some kind of obstruction is there, how the flow moves around that body is discussed here. So you can see flow around a body, flow around a cylinder and a flat plate is shown. This is the cylinder and this is the flat plate. And where the stagnation point comes at this stage. Okay, from where the separation of the fluid starts. This is the drag and lift. So a body realizes the force from the surrounding fluid whenever it is placed in a flow of fluid. A flat plate realizes a force on only in the downstream direction when it is placed in the flow direction. So that is the drag and lift. So how drag force on a particle is increased is measured here. Contributions of the frictional drag and pressure drag. This is a general expression of drag force from where we will able to calculate the cylinder drag for a cylinder and ultimately the pressure drop. Okay, so when you see that when the velocity uh, around the solid is increased, they started creating some mixing vortex. So two vortex are simultaneously getting formed. That is why it is called twin vortex. Then again the Reynolds number is increased and now the flow separation happens. So you can see the eddies are continuously shed alternately from the two sides. So now the vortex are formed in an alternate way. That is why they are called eddies and they are being shaded. When the drag for a cylinder is again increased, so now you can see that it becomes turbulent. Here also again the turbulence is increased and the flow separation will happen from there. That means the flow will be separated from that position. They will create a void space here. So this is the formula of a drag force applied on a spherical particle. These are some of the examples. Then is the expression of drag coefficient in different Reynolds number region. Then is drag coefficient of a sphere is represented by this graph. Next comes the terminal velocity. That means under gravity, at what velocity a particle can fall. So terminal velocity is calculated how? Depending on the force around the particle. So suppose this is a particle, this is an apple here, but if you think it as an particle and it is flowing through a fluid, so the kind of forces will be applied on the surface of the particles are gravity force, buoyancy force, drag force, and acceleration force. So gravity force walks downward, but the drag force and the buoyancy force acts upward. So difference between these two from the gravity force is the final acceleration force applied on the particle. So this is the expression, this is the individual expressions, and they are calculated for different Reynolds number regions. So now you can see get an expression for them. These are the examples. And finally, we will calculate the terminal velocity of a particle inside a fluid medium. So you can see this. So now we are talking till now we are talking about the straight system like a cylinder. Now it is a centrifugal sedimentation. So when you need to calculate one more term. This is the hindered settling velocity chapter. That settling, then comes the settling flux as a function of suspension and concentration. Then comes the Richardson-Zaki hindered settling velocity. This is the interface concentration measurement in sedimentation. There are many problems you can try on your own. So this is the sedimentation or flow of a body inside a fluid. Next, in the fifth lecture, Sir has talked about the Darcy's law. That means when the flow is flowing through a porous media, Darcy's law is applied. So this one is the Darcy's law. So this how this particle surface of the particle volume of the beds are calculated, that is explained in this case. So from where the Kozenik-Karman equation comes, which is the pressure drop during the flow of a fluid at a certain velocity through the porous media at a laminar condition. Okay. So this is a huge derivation. I think I have done it in the class. You can go through that. Next comes the heterogeneous industrial reactions over heterogeneous catalysts. And now the pressure drop is being calculated for the streamline or laminar or and as well as turbulent flow inside a fluid pipe. So this is solved in the class. We check and remember the final formula, because this is very important formula of the Kozenik-Karman equation, Argan equation rather. So they will definitely ask some question from it. So now the two-phase flow in a packed bed. That means some liquid is also coming inside the bed and some gas is also coming inside the bed to separate things. So this is the two-phase flow. Next comes the gas, liquid and solid hold-ups, mixing of solids. Next is the mixing of solids. Mixing, blending, how mixing, blending and agitation works. So both are same term almost, but the difference is mixing is defined as a process that tends to result in a randomization of dissimilar particles within a system. The term blending means to mix smoothly and inseparably together, during which a minimum energy is imparted to the bed. In case of blending, the external energy is required. Okay. And agitation refers to the induced motion of a material in a specific pattern. So in case of agitation, you have seen that some kind of rotor or motor is there inside the solution to induce the motion. So there are three types of mixing occurs: mixing of solids, mixing of liquids, and mixing of semi-solids. That means one is liquid and one is solid. So why mixing is important? Mixing of phases like gas, liquid, solid, either in particulates or powdered forms, is essential part for any mechanical and transport processes in chemical, biochemical, pharmaceutical and other industries. Mixing is considered as a critical factor, especially in case of potent drugs and low-dose drugs where high amounts of adjuvants are added. So this is the importance of mixing. Next is the different types of mixing. So convective mixing means group of particles are moved from one position with a pattern. And diffusion mixing means the particles are distributed over a freshly developed interface. The powdered materials are mixed in a container where the movement of the powdered particles occurs by tilting the material beyond the angle of repose. And now the shear mixing. Third one is the method is the shear mixing. So here momentum exchange of power of powder particles having different velocities leads to shear mixing. So for the mixing, different types of mixers are also present, which are active mixer and passive mixer. Under active mixer comes the ribbon blender, tumbler blender, and high shear mixing and multi-mechanism blenders. Under passive mixers, baffled and gravity embed mixing devices are there. These are the some of the pictures of different kinds of blenders. This is a batch type blenders. Okay, so it is also a batch type blender where the our feed is given in an alternative way. These are all the batch type mixers. Next is the continuous blenders. So that means the feed is given continuously and product is generated as well as continuously. These are the basic continuous blender types are pug mills, twin screw blenders, ribbon blenders, pin mixers, static mixers, and free fall impeller mixers. This is a pug mills. This is a twin blender. You can see there are twin blenders. Right here, from here is also there is a blender. From this side also there is a blender. So this is the static mixer. It depends on the direction the mixing happens due to the directional change of the fluids. Chaos-inducing elements are located along the axis of the mixer, which helps in mixing. This is a free fall impeller blenders, zigzag blenders. This is based on twin shell V-shaped blender. This is a continuous Muller. This is a kneader. Next comes the degree of mixing and it is its assessment. So how much one degree is mixing with another, that assessment is required. So that is the degree of mixing. So because how much this is mixing, the two particles are mixing, we need to quantify them. So quantification is called the degree of mixing. So here you can see there is called mixing index, which is the standard deviation. This is the ratio of standard deviation and zero mixing and the reciprocal of the ratio of S. So again, this is the formula and these are some of the problems. These are the mixing index for granular materials. Okay, so this is the formula of rate of mixing, that at what rate mixing happens between two molecules or two materials. These are the examples. Upper limit completely segregated and lower limit means randomly mixed. These are the different mixing index. Lassay mixing index of 0 would represent complete segregation and a value of unity would represent a completely random mixture. Then this is the Poulet mixing index, like this. Next comes the agitation and mixing. So three types of mixing: turbulent mixing, where highly effective mixing is due to turbulent flow, which results in random fluctuation of the fluid velocity at any given point within the system. Fluid velocity at a given point changes in three directions. Then comes the laminar mixing. So mixing of two dissimilar liquids through laminar flow, that is applying shear stretches the interface between them, suitable for liquids which require moderate mixing. Final one is the molecular diffusion, mixing at molecular level in which molecules diffuse due to thermal motion. So this is the agitator. You can see there is an impeller. So in case of agitation, some kind of motor should be there. So this is the impeller here. So different types of impellers can be used: propeller, turbines and paddles. These are the shape of the impellers and what type of flow pattern will be generated in the agitated vessel can be quantified by type of impeller, characteristic of fluid, size and proportions of the tank, baffles and impellers, and finally variations of velocity components of the fluid. This is the flow pattern, that is the vortex formation pattern, swirling pattern. So why prevention of swirling and vortex are required? In small vessels, mounting of the impeller to the center of the vessel, whereas for large tank, impeller can be mounted in the side of the vessel by installing baffles which impede rotational flow without interfering with the radial or longitudinal flow. And the third way is by using diffuser ring with the turbine. So these are the propellers, different types of propellers, turbines. So now they have shown the standard design of mixing vessel with agitators. This is the velocity component of impeller. Next is the volumetric flow rate of the fluid through the impeller. So they are trying to calculate the volumetric flow rate of the liquid flowing through the impeller. Okay. So this now finally what is written that the volumetric flow rate of liquid through the impeller is proportional to the impeller diameter, cube of impeller diameter, right? This is a power consumption to drive the impeller in turbine. So that is quantified here with this formula. These are some of the examples. Okay. Okay. So in the seventh week, Sarah taught about the basic understanding of applications and fluidization. So what is fluidization? Where a bed of solid particles is converted from a static solid-like state to a dynamic fluid-like state by means of a flow of fluid, gas or liquid. The fluid can be gas or liquid. Where the what it says is that where the solid particles start behaving like a dynamic fluid. Okay, and that is how this fluidization is used to separate, or in case of mixing in kind of mass transfer unit like that. So why does fluidized solid bed behave like a fluid? Seeks its own level. Bed height should be equal. Then objects with a lower density than the bed density will float on its surface, bobbling up and down if pushed downwards. Beds have a static pressure head due to gravity. Levels between two similar fluidized beds equalize their static pressure heads. The hydrostatic pressure rises with the depth in the bed. So these are the different types of flow patterns generated in the fluidized bed. So when there is no flow, gas or liquid is coming from the bottom in a very small, in a very low flow rate, which is the fixed bed. Now we are increasing the velocity. It is called the homogeneous bed. Next, it is again increased. It is bubbles are generated inside the bed. That is called bubbling bed. When the in the narrow shape bed, the bubbling bed, if bubbles are generated, which is called the slugging bed. Next, when the gas velocity is much more increased, the chaotic movement of the fluids and particles will form a chaotic mixture, turbulent mixture, which is the Chern turbulent bed. Next, that after the turbulent mixture, that some of the particles will overflow, and the fluids inside the some of the particles along with the fluids will overflow, and the density of the particles will be lesser inside the fluidized bed. So that is the moment of fast fluidization. And when the uh, particle density is very less inside the fluidized bed, it is called the pneumatic transport. So these are the different stages of fluidized bed at different gas velocity. These are the elements, different types of beds, how they look. So how fluids or gas can enter into the fluidized bed is batch mode, concurrent mode. You can see the figures and you can relate. Cross flow mode, that is the solid and gas is coming in opposite direction. Counter current mode and inverse mode. Okay, so for this cases, for this packed beds, ease of handling is there, good mixing between the particles is there, continuous operation is there, heat transfer coefficient, mass transfer coefficients are very high. Then good for exothermic reactions, more compact efficiency, large scale operation is required. Next are the disadvantage. What are the disadvantage of the fluidized bed are difficulty in plug flow, entrainment problem, capital cost is high, size problem is there, erosion problem, because there are different shapes and size of particles inside there. So there is a lack in equality of the particle size. Then back mixing is there, complex hydrodynamics is there. So these are the applications of fluidized bed. These type of beds are also used in different kind of industries. For physical operations, drying, for pharmaceutical industry, combustion and pyrolysis industry, in hydrocarbon cracking and silicon production, everywhere it is used. So these are some of the commercial applications. This is in coal combustion it is used. Chlorination of uranium oxide it is used. Natural gas combustion it is used. Reduction process of iron ore it is used. So these are the gas solid liquid reactions of the fluidized bed. So in catalytic cracking, fluid bed is used. So you can see this. Now comes the minimum fluidization velocity. So here comes the minimum fluidization velocity moment. So at a velocity, all the particles are just suspended by the upward flowing gas or liquid is called the minimum fluidization. That means that just fluidization is starting inside the bed. What happens? At this velocity, the frictional force between particle and fluid just counterbalances the weight of the particle. The pressure drop through any section of the bed about equals the weight of fluid and particles in that section. The bed is considered to be just fluidized and is referred to as an incipiently fluidized bed or bed at minimum fluidization. So at minimum fluidization you have seen that drag force by upward moving gas and apparent weight of the particles will be equal. So that is how these formulas are formed. This is again the pressure drop calculation. This is the Argon equation. So in the minimum fluidization condition, the Argon equation is a little bit different from the normal fluidized condition. These are some of the examples you should be able to do on your own, because in exam it may come this type of question. Next is the basic understanding of froth flotation. So froth flotation is a process that selectively separates material based upon whether they are water repelling, or that means hydrophobic, or have an affinity for water, or hydrophilic. The process of froth flotation is dependent upon the density of the material and its hydrophobic nature. Okay, so this is the basic principles of froth flotation. So particles will be adhered to the gas bubble, and the gas bubble will try to come out of the mixture, and along with the bubble, these particles which are absorbed at the surface of the gas bubble will also come out. Okay, so these are some designs. These are the collectors. Collector means which are used to make the mineral surface hydrophobic are called collectors. So some activators are also given, depressants are also given, pH is also maintained for in the case of froth flotation. So this is the flotation kinetics. If you go through it, you will understand. Okay. Next is the separation of particles by screening. So you know already I have told that you know screening, how these are separated. Different sizes of particles. Even in the industry also a screening method is used because of the ease of handling. This is a different type of screens. This is a centrifugal shifter. This is the screen efficiency. Screen efficiency or effectiveness is basically a measure of the success of the screen in closely separating the materials A and B. The screen functions perfectly. All the material A would be in the overflow and all the material B would be in the underflow. Next is the how these effectiveness or efficiency of a screens are calculated. So based on these fractions, you will be able to calculate the overall screen efficiency or overall effectiveness, screen effectiveness. This is a formula coming from the some simple calculation. So these are the problems on that. Capacity and effectiveness of a screen. So the capacity of screen is measured by the mass of material that can be fed per unit time to a unit area of the screen. The capacity and the effectiveness are opposite factors. That means to obtain maximum effectiveness, the capacity must be small. The large capacity can be obtained only at the expense of a reduction in the effectiveness. The capacity of a screen is controlled simply by varying the rate of feed to the unit. The effectiveness obtained for a given capacity depends on the nature of the screening operation. So now the mesh sizes are important in a screen, right? So the fraction of the total surface represented by the openings, the ratio of the diameter of the particle to the width of an opening, the number of contacts between the particle and the screen surface. So number of openings per unit area is proportional to the inversely proportional to the square of the size of the largest particle The mass of one particle is proportional to the cube of size of one largest particle, and the capacity of screen is proportional to the largest size of the particle. Next comes the particulate matter separation by gravity settling. So I have said that particulate matter is a pollutant consisting of a mixture of solid and liquid particles of inorganic and organic substances suspended in air or liquid. The particle matters are mainly the products of combustion or aerosols nucleation. The industrial sector is responsible for 17% of all the particulate matters. This is with 2.5 micron to 10 micron. Particles always float in the sky or in environment. So these are need to be removed. So these are the principles of the removal. Then this is the mechanism of separating particles, that is the sedimentation, migration of charged particle in an electric field. So what is sedimentation? The particle containing gas stream is introduced into a device or chamber where the particles settle under gravity to the floor of the chamber. Devices of this type are called settling chambers. Okay, so due to gravity, the particles are settling down at the bottom of the chamber. Next one is the migration of charged particles in an electric field. The particle containing gas stream is introduced into a device in which the particles are charged and then subjected to an electric field. So the separation happens between the difference in the electric field potential. Next one is the internal deposition. When a gas stream changes direction as it flows around an object in its path, suspended particles tend to keep moving in their original direction due to their inertia. And fourth one is the Brownian diffusion. Particles suspended in a gas are always in Brownian motion. When the gas stream flows around obstacles, the natural random motion of the particles will bring them into contact with the obstacles, where they adhere and are collected. So these are the some of the main equipments of the particle separation. Definition of collection efficiency and overall efficiency. Next is the penetration or grade efficiency of the particles. This is the example of settling and gravity chamber. Okay, so these are the particles are stored in this chamber at the bottom. So this is the formula of turbulent flow settling chamber. Next comes the cyclone separator. So here centrifugal force is used applied on the particle surface. So you have seen it is also written that utilize the centrifugal force created by a spinning gas stream. A particle is acted on by a centrifugal force which is mv square by r. The gas flows is forced to follow the curved geometry. The inertia of particles causes them to move toward the outer wall where they collide and collected. So this is the principle is very easy for a cyclone separator. Different types of cyclones are also used. This is the equation for the trajectory of a particle in the cyclone separator. This is the calculation. You can check it. Now, what are the variables affect the cyclone collection efficiency, cyclone separator collection efficiency? So, this is the collection efficiency increases with increasing particle size, particle density, inlet gas velocity, cyclone body length, number of gas revolutions, and smoothness. But collection efficiency decreases with increasing the cyclone diameter. So we have to cyclone gas outlet diameter, gas inlet area. So we have to manage both these parameters to get maximum efficiency of the cyclone separator. This is a separation by centrifuge. Next important one is the electrostatic precipitator. These are one of the most widely used particulate control devices, ranging in size from those installed to clean the flue gases from the largest power plants to those used as small household air cleaners. So here particles are separated depending on the difference in the charge of the electrode. So particles are charged by means of a corona which is established surrounding a highly charged electrode which releases electrons at several thousand volts. Then an electric field is imposed on the region through which the charged particle with gas is flowing. The electric field causing the particle to migrate to the oppositely charged electrodes at right angles to the direction of gas flow. The collective layer of particles on the electrode plate is removed periodically by wrapping it. So, I have shown you the videos also, so probably you remember that how this electrostatic precipitator works. So, particles are charged and they are getting when the electric field is applied in the setup, these charged particles are getting attracted to the oppositely charged electrodes, and that is how they are separated. So, there are two type of charging: field charging and diffusion charging. Field charging, ions are accelerated towards the particles by the external electric field, and diffusion charging is caused by the irregular thermal motion of the ions. This is the bag filters. Next is the industrial bag filters. Is a filtration process is usually accomplished in a so-called baghouse in which the particle-laden gases are forced through filter bags. Particles are generally removed from the bags by gravity. These are the filtration process. In first stage, the particles collect on the individual fibers. In the intermediate stage, particles accumulate on previously collected particles and bridging the fibers. In the final stage, the collected particles form a cake in the form of a dust layer that acts as a packed bed filter for the incoming particles. This is the materials used in the filters. There are huge applications of the different types of filters used in the industry or any other places. These are the selection criteria. Air to cloth ratio in various industries. This is the formula of efficiency of filtration. Next is the wet scrubber for particle removal. So scrubbing is a very effective means of removing small particles from a gas. Wet collectors or scrubbers employ water washing to remove particles directly from gas stream. Removal of particles results from collisions between particles and collecting medium. Next is the wet collectors or scrubbers ratio type 1, in which an array of liquid drops form the collecting medium, which is a spray tire, cyclone spray tower, spray baffle scrubber. And second one is in which weighted surfaces of various types constitute the collecting medium. Plate scrubber, Venus scrubber, packed towers. Next is the spray scrubber. This is the cyclone scrubber. Drops can be introduced into the gas stream of a cyclone to collect particles. The spray can be directed outward from a central manifold or inward from the collector wall. There is a baffle scrubber, venturi scrubber, that means there is a venturi type shape you can see in the scrubber, that is called venturi scrubber. Next one is the packed bait scrubber. The efficiency of the scrubber, advantage and disadvantage of the scrubbers. Then collection efficiency of a spray scrubber, and that is the filtration is done. Scrubber is done. The 10th lecture is about the filtration, the process by which particles are separated from a particle-laden fluid, liquid or gas, or by a filter medium that allows the fluid to pass through it at a driving force and separate the solid particles in it. So filtration process is very common to us. We also use the filtration process in case of our drinking water. You can see this is the feed particles. This is the filter medium where bigger particles are stopped and smaller particles or filtrates are going away. Filtration driving forces of the filtration are gravitational force, centrifugal force, application of pressure, electric force, and concentration. Okay, so this is the basic components of filtration: filter membrane, compressor, support, wrapper. These are the different types of membrane is used, that is a solid membrane, liquid membrane, microfiltration membrane. The range of separation sizes are different: ultrafiltration membrane, nanofiltration membrane, reverse osmosis, electrodialysis, and dialysis membrane. And different types of membrane materials are used. So all these processes are explained in the individual classes with proper videos from YouTube and other explanation, and problems are also done. I hope these when I am revising it, you can remember those things. This is a membrane configurations, the permeate membrane and cross flow filtration and dead end filtration. Then the general membrane equation is also calculated. And finally, we'll get the expression. This is a membrane fouling, then different factors for membrane. Next comes the dead end and mineral formation, column cross flow filtration. Dead end filtration through the membrane permeate passes through it. All the particles are retained in the membrane. And in the cross flow filtration, where the feed flows tangentially to the membrane and permeate passes through, only a fraction is converted to permeate product. Next is the plate and frame filter. This is a Kozinski-Kármán equation for pressure drop applied across the filter. This is a cake resistance and medium resistance inside the filter. Okay, so the detailed solve of the derivation of the uh, equations are done in the class. I am not doing it again today. This is the osmosis. So osmosis is the movement of a solvent across a semi-permeable membrane toward a higher concentration of solute. But reverse osmosis is the opposite one. Involves the forced passage of water through a membrane against the natural osmotic pressure to separate water and ions. This is a theoretical analysis of the reverse osmosis. In the last two class, Sir has taught about the nanoparticles and the adsorption. So in the nanoparticles, that size, smaller size widens the trend. Because of smaller size scales, particles can behave differently than their bulk counterparts. As particles become smaller, their surface area increases greatly, and this allows for properties such as increased electrical and thermal conductivity, lowered melting points, stronger magnetism, unique optical properties to arise. This is the nanoparticles or nanomaterials. like what are the properties of nanomaterials? Activation of the particle surface, increased surface area. Then comes the morphological and structural properties of nanomaterials, electromagnetic properties, optical properties, mechanical properties, contact angle, and classification. So it is the overall the nanoparticles and its use and its enhanced properties because of their small nano size. This is a synthesis method, chemical and physical methods are there. So bottom up and top down methods are there for creating nanoparticles. So that is explained in the second chapter. And in the third chapter also, the chemical methods are explained, where there is CVD, microemulsion method, okay, the sol gel methods, etc. In the last days, I talked about the adsorption principles and applications. So you already know the absorption. So Sarah has talked about the adsorption and how it is important in the industrial applications. And inside the adsorption, ion exchange adsorption and chromatography, adsorption and chromatographies are two important parts. So that are discussed in detail, and also if you go through the each classes of mine in throughout these 12 weeks, you'll get to know better these chapters. So what are adsorbent, what type of adsorbents are used, what is adsorbate, everything is, what are the adsorption equipment is used. So everything is detailed in this chapter. This is a different type of isotherm, Langmuir isotherm, Freundlich isotherm are used in case of adsorption. Different type of models. Uh, first, uh, first mechanism, second mechanism, third mechanism, and fourth mechanism. Then comes the pseudo first order model, pseudo second order model. Like this, you can calculate the rate of absorption. So this is the whole of Sir what has Sir taught the overall process, and I hope when I have gone through the chapters individually, it was clear. So now we are going to do some very easy problems. Okay. So the first question is, a sponge iron industry uses a reciprocating screen of 5 mm aperture to separate oversize is our product here, so be careful, from undersize fines, which is then recycled to furnace. The screen analysis of the furnace output was found to contain 25% fines. The screen efficiency was known to be 50%. The underflow from the screen contains around 95%. If the furnace production rate is 100 ton per hour, find the amount of fines present in it. Okay. So here we will do the solve. So there was a diagram also here. So what was the diagram? So that is saying that this is our furnace where feed is in 100 ton per hour. It contains 25% fines. Okay. And the overflow is our product, oversize is our product, it is D, and underflow is B, where there is 95% fine. So we need to calculate it, like the overall screen effectiveness. So first we will define F is 100 ton per hour. In the XF, the fine is in 25%. That means XF is the oversize mass fraction of oversize in feed. So this one is the, because oversize is our desired product, we will based on that mass fraction of oversize in feed. So it is 1 minus 0.25, that is 0.75. Next, mass fraction oversize in underflow, that is 1 minus 0.95, because 0.95% is the fine, so it is 0.05. And the screen efficiency is told that it is 50%. Right? So now what is the overall Screen's effectiveness formula xt into 1 minus xb xf minus xb xd minus xf divided by xf 1 minus xf xd minus xb whole square. So now we know 0.5 is E. We don't know xd. xd needs to be known, right? So it is 1 minus 0.05, 0.75 minus, minus 0.05 xd minus 0.75 divided by xf is 0.75, 1 minus 0.75 into xd minus 0.05 এর whole square, right? So finally, what we'll get? So after the calculation, you will get xd square equals to xd square minus 0.855 minus 0.00041 equals to 0. So from here, xd will be 0.8555. This is the amount of oversize in product. But what is the question asked? Amounts of amount of fines present in the product. So obviously it will be the minus. So amount of fines in the product will be 1 minus 0.8555 equals to 0.1445 equals to 14.45%. This is your answer. Okay. Okay. Did you get it? So you have to be very careful. If the undersize only is if the fines is your product, right? If the fines or undersize is your product, the problem will be different, right? Now we'll do very simple two problems and we'll end this lecture. So find the sphericity of cuboid. Find the sphericity of cuboid of 10 into 5 into 1 centimeter cube. Okay. 10 into 5 into 1 centimeter cube. So in the sphericity definition, you know that it is the surface area of sphere of equivalent volume to the particle and surface area of the particle. That means their volume is same. So volume of sphere is 4/3 pi r cube, which is r is not known of the sphere, and volume of cuboid is 10 into 5 into 1. So we'll calculate r from here. So r will come as, if you calculate r, you will get r as 2.285 meter. Okay. Now phi s we will know that surface area of the sphere is 4 pi r square divided by surface area of the is 10 into 5 plus 5 into 1 plus 1 into 10, right? It is 0.504. So the answer is 0.504. Now I'll do a very simple problem of mass mean diameter. So there is a chart and mass mean diameter needs to be calculated. This is your xi, the mass fractions and the average diameter in millimeter. So 0.2 in that is 5, 0.4 that is 10 and again 0.4 that is 20. So what will be the mass mean diameter? So mass mean diameter expression you know, right? It is dW equals to summation of I equals to 1 to n xi to dpi, right? That means just it will be the multiplication of each into plus adding everything. So 0.2 into 5, 0.4 into 10 plus 0.4 into 20. And it is coming as 1 plus 4 plus 8 equals to 13 millimeter. This is your answer. Okay. So I have done many problems on Rittinger law and Kick's law, so I am not doing it. Then roll crusher, ball crusher problems are also there. So if you go through my lectures, you will get the problem. That type of question only will come. Okay. Then the fluidization, terminal velocity problems are there. You revise those problems again. Try to do it on your own. You will get to do it. So then nothing is new here. Minimum fluidization velocity problems. Many problems sir himself has taught in the class. So all those problems are very important because the question will come from there only. Not many tough question will come, but you have to remember the formulas. Okay. So I hope this lecture series is helpful to you. That's for today. Okay. That's for today and that's for the whole session also, the solid fluid operations tutorial sessions. So I hope you have found those lectures, my lectures as well as us lectures helpful to do your every week assignments. And also I have done some extra problems in the class. You go through all the problems and all the questions, all the discussions, all the videos I have shown, it will be definitely helpful to you. And if you still have any question, you can raise the concern. And all the best to you for your coming exam. We'll meet maybe in next semester on some other time. And till then, goodbye. Thank you for joining the classes.